Alright, so today we are going to talk about conditional probability, which you've actually seen this notation before. It was the probability of A and B. It was two dependent events, okay, where you take the probability of A given B and times it by the probability of B, okay, given that A has happened, okay. Alright, so some examples of how this stuff actually works is if we take a look at a problem that looks like this, let's say we were looking at, and this was huge back in the day, so I'm just going to reuse it. Okay, hair growth versus no hair growth. Okay. All right, let's say that 1,600 people are here, 800 are here, and usually this is going to be guys, but sometimes there are women in these studies because there are women baldness. Okay, so what this is actually saying is the hair growth. Let's say that everyone was taking the study. These were the numbers that were actually found, and if you take a look at them, you're like, oh, those look pretty darn good for it. Okay. What you want to do is right off to the side, especially when you're dealing with the table, add them up just so you can actually work with them. Okay, and I'm talking about add the rows here, or the columns here, and then add the rows down here. So this would be 1,600. This would be 2,400. Okay, so looking at some of this stuff, this will actually help work with this, with us actually finding it. Okay, and you can actually use tree diagrams here as well. Okay, what is the probability that a test subject's hair grew given that they used the experimental drug? Okay, so what we're going to be doing is we're going to be looking at these numbers right here because we're looking at the drug users only. That's the given. So the given was the drug. So the way the problem would be set up is probability that there was growth in the hair given that they were using the drug. Okay. All right. So as we work with it, it's going to be pretty easy to actually work with. Okay. So what we're going to do is that's going to be the probability of growth and the drug have been used. Growth. There we go. And then we're going to divide that by the probability of just the growth. No, probability of giving the drug. My bad. Had to think about that for a sec. I was like, wait, what? That doesn't make... Okay. All right, so the probability of getting the growth in the drug, okay? All right. We would add it all up, and if you notice, if we add these two, there's going to be 4,000. So this will actually be 1,600 divided by 4,000 on top, okay? And then on the bottom, okay, given that they use the drug, that would be 2,400 out of 4,000. Okay, because there's 4,000 total as we work with it. All right, now, from your experience, when you divide by fraction, you multiply by the reciprocal, you should get 1,600 divided by 2,400. Okay, and if we get rid of those zeros, we can reduce it down to 16 over 24. And then if we divide both sides by 8, we should get 2/3. Okay, so the probability that a subject's hair grew given that they used the experimental drug was actually 2/3. And that's actually a pretty darn good probability to work with, too. Now, what you could also do is you could use a tree diagram just to work with it. Okay. All right. So we would actually have two given effects. Okay, so the first part is the given, so it's the drug. Okay, and this one would be the placebo. Okay, so this would be the 1,600. Well, this would be the, let me see, 2,400 out of 4,000. Okay, and then this one would be 1,600 out of 4,000. And sometimes it's really nice to actually draw out all this stuff. Okay, let's rewrite those numbers again. So this would be 2,400 divided by 4,000. Okay, so those are the probabilities as we go. Now this would be the actual growth. So the actual hair growth would actually be, let me see, hair growth would be 1600 divided by 2400. Okay, and then this one would be no growth, none, which would be 8 divided by, or 800 divided by 2400. Okay, and then this one would be growth, would be 1200 divided by 1600. And this one would be none, which would be 400 out of 1600. Okay. Now, just taking a look at these things real fast. These numbers are actually the and. So this is these are the and numbers. This is not the given. Okay. So if we actually wanted to find the given, we would divide, well, technically, yes, these are the givens. These are the actual givens as we work with them. That's my bad. This is a great way to just check your work as you work with it and stuff, okay? All right. Now, conditional probabilities, you do need to take your time and actually work with them and realize that there are two formulas to work with. But conditional probabilities, these are for dependent events, and they are just working off of this information. So you're going to work off of tables, you're going to work off of tree diagrams, and you're going to actually work off of actual calculations given to yourself. But if you list out, if you're given, for example, on this one, there are 3 variables in here. There's probability of A and B, probability of A given B, and probability of B. If you know 2 of them, you know that you're finding the 3rd one. So if you're really confused on these type of questions, just take your time, write down what each probability is, and if you can actually write it out and get an actual answer and it makes sense, you know which formula to use to actually find either A given B or A and B. Okay? And that's just the experience of working with this. It just makes total sense after you do it for a while, but for the first part, you might just be going, huh? And then just working with it that way, okay? All right, that's it for conditional probability. I'll talk to you later. Bye.